John Yoder is a professor of plant sciences at the University of California, Davis. While his current work is agriculturally focused, John received his PhD in medical genetics from Stanford University, dissecting the genetics of the human herpes virus. He continues to be interested in both human and plant biology and is fascinated with how the simple cannabis plant has impacted human society. Today, Dr. Yoder is going to give an overview of the domestication, evolution, and uses of cannabis sativa around the world.
Why do this course? Why do you have a course on cannabis? What's the point of it? Cannabis has been used since the beginning of people time. So we're talking 10,000 years ago, beginning of agriculture. It's probably pretty clear that the hunter-gatherers were pretty good experimental botanists, right? They didn't have stores to go to. They had to figure out from the field what to eat and what to make clothes out of. And there's a lot of cannabis around, and they used it. It's been thought to probably be one of the first domesticated crops, but I'll show you evidence this has been used for 10,000 years. That being said, in the US and much of the world, cannabis has been under prohibition since 1930, which means we know very, very little about that, which means we haven't been able to do any research. So it's an interesting scenario where you have a plant that's been used for 10,000 years and people today know very little about it. So it seems like there's a lack there. We just don't know enough information. So I think education's probably right. The other thing is, we're found recently, or in the last 20 years, is these plants make molecules that are very bioactive at the neurological level. They have anti-pain properties. Some of them have sleep, appetite control. I'll show you that with the endocannabinoid. So this is a plant that has very much medical potential to it. And the fact that we haven't been able to study it for the last 50 years, you'll see that's kind of set things back a little bit, right? Finally, it's a legal crop. It's probably worth about $5 billion next year, 250,000 jobs. So let's start with the plant. The thing with cannabis, it really likes sunshine, it likes open areas, and it grows just wildly all over, throughout much of the world. You'll see that. A lot of these pictures, I have to point out, Clark and Merlin, they wrote this book, Cannabis Evolution, Ethnobotany from UC Press. I'm going to refer to them a lot. But what they're showing here is, here's feral plants in western Nepal growing. This is used both for seed and for drug purposes. They're feral, meaning they used to be domesticated and they escaped. They found on waterways. There's a picture in India. It's thought that waterways is probably where a lot of civilization would start, right? Because you've got water, you've got movement, you've got fish, you've got all that stuff. So where hunter-gatherers would settle down would be near a waterway, and cannabis loves that type of area. It also grows really good around communities. Kind of grows in community waste dumps, if you will, right? Where we have waste, it's very high nutrient. Usually people come in, they clear an area, they have a lot of nutrients, so it grows very well around there. And then finally, it can be grown even ornamentally. It can be seen sometimes. So there's a plant that's a lot of places, and certainly people know how to use it. It has a lot of uses. 3 uses, really, which we're going to talk about. One is hemp or fiber, and that's seen up in the upper left. And depending on it's a very morphologically adapted plant. There's a lot of changes it can go to. And depending on what you want to use it for, you cultivate it for different reasons. So when we cultivate for fibers, you see in the Netherlands up here, it's very close spacing. They want nice, tall, long shoots, which are these long sativa shoots. And that's where they want to get fiber from that. You strip the bark off. I'll show you the process in a bit. It can be grown for seed. This is in China, a seed production facility. And here the idea is that you want branching to go on. So you plant at a lesser density. You encourage branching in order to gather the seeds. And then there's the drug use. Here's a picture in Switzerland. Clonal propagation, micropropagation, and you look at this field, it's beautifully uniform, right? So it's a uniform, consistent area, and that would be a use for drugs. So depending on how it's used, it can be grown different ways. 1 or 3 species. Carl Linnaeus, 1753, right? The father of taxonomy. He said there's 1 species, cannabis sativa, so we're going to stay with that. Some people say there's 3, some people say not. But basically, they're all cross-pollinating, and we're going to call these varieties or subspecies. So there's one species, Cannabis sativa, whether you grow it for rope or whether you grow it for drugs. But there's subspecies within there. And again, some people would call those species different. Sativa and indica are grown for rope and hemp purposes. Both of these are grown for drug purposes. And ruderalis is not really grown very much, but this is an interesting guy because it is day neutral. So where the rest of these are long day, short day plants, right? They vegetative in long day, they flower in short days. This is a day neutral. So it has been possible to cross this with these and introduce what's called auto flowering. So now there's plants, there's cannabis plants that just flower automatically. Probably a more practical designation is this right here, which is fiber types, which you grow for fiber and cloth and whatnot. They tend to be very low in THC, and this is what we call hemp. Seed types, and then drug types. Drug types are what we're going to call marijuana types, right? And cannabis represents all of that. These have very high THC and high CBDs. There is a group from Toronto, from Canada, a genome sequence of this purple kush. There's a genome browser there. Dioecious plant. This means you have males on one plant and female flowers on another. This is not uncommon in plants. About 6% of species are dioecious. Dioecious is what the name di, right, for two plants. Of course, things germinate. They grow into a juvenile phase for a couple months. There's really, at this stage here, there's no differentiation between male and female. It's not until they flower that happens. It's a photoresponsive flowering, as I said, so long days it grows vegetatively. The days start to shorten, it starts to make flowers. And it makes two types of flowers, which are shown here. So one plant makes these female flowers, which is this little white bud, and male flowers are the stuff up here. Flower looks like, it's basically two stigma and a bract. So the pollen's going to land here, swim down, fertilize here, and it's going to make the seed right here, right? That, and then on the male side, it looks just like a male flower. It's got anthers, filament. If you cut this open, pollen comes out. It's an XY sex system, so it is a chromosomal basis. Like humans, it doesn't have to be. Plants do a lot of different things. And there's molecular markers that have been developed, so you can screen seedlings now for whether it be male or female. Cannabis is in a family of rosids called Cannabinaceae, right? That's the family. The other two plants that you know of, which are in that same family, are hops, right? Which go into IPA. That's your Indian Pale Ale hoppiness, right? And celtis, which is hackberry trees, which are all lined up throughout all in Davis. So this family has cannabis, hackberry trees, and hops, humulus. Okay. What happens is the plant is wind pollinated, and the male flowers release pollen, as you can see, lands on the female and sets seeds. Seeds are botanically called achenes, which means they're actually more of a fruit than a seed. It's a fruit. If the female flowers do not become fertilized, then they just continue to grow, and these are called without seed flowers, or sensimilla seeds. Sensimilla, without seeds is really. So that's a little bit of the basic botany. There's one other botanical point here, which is really important. And these are these little hairs on the plant. And these are called trichomes, and most plants have trichomes, and there's a whole bunch of different types of trichomes. They're protuberants that come from the epidermis of the plant. They can be on the leaves, on the stems. And there's at least two types in cannabis. There's this, which we call non-glandular, which are just like little hairs. Those aren't really what we're most interested in. We're most interested in this type right here, which are glandular trichomes. And the reason is these are basically little factories for making secondary metabolites. And the idea is it's done for host defense against herbivores, against fungi, because it's out on the outside of the plant. You're making these chemicals that are sticky, and that prevents things from eating it happening. So the different types, and the bulbous, or this captate, is the one that we are particularly interested in. And what's interesting here, so these trichomes are what makes where the drugs are being made. That's where the secondary metabolites are being made. These trichomes are particularly prevalent on female flowers for reasons that I have no idea why. But if you look here, here's a female flower, and all these little sparkly dots here are these trichomes. They cover the flowers, in particular unfertilized flowers. Here's a picture of a close-up of what the trichomes look like. Is once the female plant becomes fertilized, it stops making these trichomes, shuts that process down. So if you have unfertilized females, you build up a lot of these trichomes. As soon as it gets fertilized, that process shuts down. Really, the two molecules that we're really talking about in cannabis are these terpenes and cannabinoids. Summary of this kind of cannabis biochemistry, and there's really three pathways that really chemists and of cannabis need to be concerned about. The first is unique to cannabis, and these are these cannabinoids. We're going to spend a lot of time on this because this is where all the kind of medical interest and all the psychological interest is all on these things, and it's unique to cannabis. Terpenes, whether it be monoterpenes, sesquiterpenes, it depends how many groups are on there. These are the things that give the quality of the smell. This is what makes things smell like pine or lemon or pineapple. And then the last group are flavonoids. Flavonoids are in most plants. They're flower, scents, things like that. But there are some particular flavonoids that are unique to cannabis. And so talk a little bit about these cannabinoids. Again, Lee Tien is going to come give us talk, and she'll explain all this in detail. There's about 120 different types of cannabinoids which have been identified. They fall into about a dozen families. These families I listed down here. This is kind of a busy slide, but this is, I think there's 15 here. CBN, CBG, CBC, all those different molecules. And again, we'll get into more detail here, but there's a wide swath of these, which is important. So 120 cannabinoids that have been identified in there, all with these kind of similar structure. Only one of those is psychoactive, and that's THC, delta-9 THC in particular. We'll see in plants, this can be many percent of the flower weight. Another one, though, which has been a lot of interest, is this cannabidiol, or CBD. They're found in roughly equal amounts in plants. THC, CBD, cannabidiol is one of the most prevalent, other than THC, of the cannabinoids in there. It tends to counteract THC, and there's some examples of where they made synthetic THC as medicines. People took it, and it was too much. It was too much. So then they mix it with CBD, and it brings people down a little bit. We're going to get to this concept in a little more, but there's not just one drug that's doing it. It's a mixture of molecules. But that's the cannabidiol. These are present even in low THC lines. So you can define cannabis by its chemicals, chemolars, right? And drug types have a lot of THC in them. They have more THC than CBDs. THC is usually in the couple percent range. This can be up to 30% under certain selection procedures, right? THC very high. Intermediate types, THC and CBD is about the same. And then there's hemp types or fiber types, where the THC, the CBDs, are a lot of CBDs, not very much THC. These are low THC lines. THC, CBD, CBC, all derived from this one stem cell molecule, if you will, CBGA. That's where they're all derived from. So it's one common precursor, and then they go from there. So the plant makes cannabinoids in a carboxylated form. These are called the acids, THC acid, CBD acid. That's this little carboxyl right here. That's in the plant. You take it, but when this gets heated, that carboxylase comes off, and that actually activates some of these molecules. THC in particular is not active until you take that carboxyl off. Now, that's true for all these cannabinoids. They're all carboxylated, but we don't know what that's doing. All right, so I wanted to talk a little bit about the historic diffusion of this plant. Again, it grows in sunny, newly cleared areas. So so the idea, it was originated pre-domestication, Mongolia, Siberia, Central Asia somewhere. It's kind of hard to track that down, because what you look for when you do this is you look for centers of diversity, right? And you say where the most diverse plants are. The problem is with cannabis, it's been grown so long and moved so much, is that there's feral plants all over here. So what happens is people grow it for a while, then they leave it in the field, and 5,000 years later, it looks like a wild plant, but it used to be domesticated. So it's not very easy to track down. But this is the general consensus, is that it probably was up in Central Asia. It moves, it gets migrated, farmers move it, take it, and some of it moves down towards India, towards South India, Thailand, Afghanistan. These evolve into drug types. These are the types that are what you get in Humboldt County type ones, right? Then also some of these were carried up north, and they evolved into more of the fiber types, right? Because that's what they were useful. The oldest known civilization is this Yangzhou in China. It goes anywhere from 5,000 to 8,000, 3,000 to 8,000 years ago BC. And there are pots from that area that have hemp markings on them. These little straw, these are the fiber markings. It's not clear if they put it on for a decoration or the help makes, it's not clear why they're on there. Old paintings, hieroglyphs. This guy Herodotus actually gets to the drug aspect. This is in Roman baths. And apparently after their steam bath, they would throw some seeds onto the fire and sit around and delightedly shout for joy. Confuses people because there's not a lot of THC in seeds. It's not clear why they were doing that, but that's what he wrote. It moves up into Japan and Korea. Used a lot for cord fiber up here. Confucian philosophy apparently is not consistent with doing a lot of drugs, so they did not really develop the drug use up here. It was used mostly for cord and seed. India does not have that problem. So when it was moved down to India, they started developing as drug types. And Ganja, right, is the god of the Ganges River, where we get the Ganja name from. Moved over from the Silk Road, moves up into England, up up in 1,000 years ago, 1500 BC, AD, later on. English colonialism needs hemp. They need it for sailboats and they need it for fiber. This is their way of life, right? Colonialism requires hemp, so they got it. So that's where it is here. So I'm going to talk about the three products. I'm going to start with hemp, and then I'm going to go into seeds, and then I'm going to talk about the medical cannabis, right? The cannabis sativa, again, the T is defined chemically. If it's less than 0.3% THC, that is hemp. That is non-THC live. That's legal definition of this stuff. It's used for hemp sales, and in the 1700s, everything was a sailboat. It's everything. It was a very valuable crop. Doesn't degrade. Clothing, paper, rituals, plastic parts. I didn't realize this, but they can make cars out of that. Plastics as well, and any kind of building supplies. It's widely used that way. A little bit of pictures, again, Clark and Merlin, I have to refer to them as well, talks about hemp production. And as we talked about, you want to have, it is planted at very high dense spacing, so things grow tall and straight, and it's harvested, in this case, by hand, or we'll show you some cases of machine harvested. It's transported, it's soaked for a while, this kind of freeze, there's a microbial action that frees the bark. The bark is where the fibers are. So they soak it in water, they dry it out, and then you strip off this stuff, you strip the fibers off of that. It goes to the textile mill, and it gets turned into textile and clothing and stuff like that. That's the general hemp production, and again, that's going to happen pretty much all over the world. A couple pictures here. One is, harvesting hemp in 1956 in the Soviet Union, harvesting hemp by machine in France. And this is interesting, in the U.S. So there was a big push in the U.S. For hemp production. And here's what happened. Hemp was in the founders' DNA, if you will, right? Because there was so much need for rope. Again, the colonials needed rope and sails. That when they sent their colonists over here, they said, grow hemp. That's what they told them. So the first colonies at Jamestown, that was their role, grow hemp, right? George Washington grows it. Thomas Jefferson, James Madison, all the early guys in the 1700s, right? That's a normal thing to do. It was a significant component of Kentucky And then what happens, let me finish the story and I'll get right to you. And then what happens is we start getting foreign products which replace hemp. Things like sisal or jute or manila hemp. So what happens is the hemp market starts to go down in the U.S. because there's other sources of rope, basically. And then, which I'm going to tell you in a few minutes how this happens, in 1937, the U.S. says it's all illegal. We're going to make it all illegal. You can't grow hemp anymore. So that, of course, crashes that market until World War II comes around, 1940. And then what happens is the Japanese have control of all those other rope things. They have control of manila hemp. They have control of the sisal. They have control of the jute. So now, for the war effort, we got to start growing hemp, right? And we do. This is put out by the USDA.
The Conestoga wagons and prairie schooners of pioneer days were covered with hempen canvas. Indeed, the very word canvas comes from the Arabic word for hemp. In 1942, patriotic farmers, at the government's request, planted 36,000 acres of seed hemp, an increase of several thousand %. The goal for 1943 is 50,000 acres of seed hemp. Program. This film is designed to tell farmers how to handle this ancient crop, now little known outside Kentucky and Wisconsin. This is hemp seed. Be careful how you use it. For to grow hemp legally, you must have a federal registration and tax stamp.
Yeah, so even then, so it wasn't a legal product, but here you have the USDA with patriotic music in the background saying it's your job to grow hemp. That's kind of an interesting contrast. Okay, cannabis seeds. So that's the hemp. That's really where the stuff starts. The story that Clark tells is when cannabis falls in the fall, when it grows onto the ground, it degrades over the winter, it falls apart, and by the next spring, you still have a lot of fibers left over. So those would be really obvious to anyone that knew anything about it. Okay, so seeds, they've been found in Japan, 8,000 BC, so they were grown in Japan. And most of the hemp seed in Europe actually goes to bird seed. But again, depending on what you want to do with it, you grow it different ways. So you can grow hemp. This is in China, I think. Yeah, Shandong, China. They grow it with a wider spacing where they promote branching, and then they can walk around and fertilize it. The branches then are laid out to dry, and they're winnowed. Here's the seeds down here left over from those stalks. They shake those seeds out. There they are. And then they're edible products. So you can eat that. This is an interesting picture again from Clark and Merlin. This is in the Himalayan in western Nepal. And this family is using all three of those products. This is in Nepal. They have a very high density garden. They harvest the entire plant, chop it off, bring it back. And then at home, they then take the seeds. So they use the seed for food. They use the fiber for textiles, right? And then what these folks are doing, they're taking the flowers, right, and rubbing it. And then you get all that sticky stuff off, right, which turns into hash, or in this case, they're calling it charas, which is this right here. So in here, they're using all three of those, right? They're using medicine or drug type, seed, and fiber all at the same time. But I wanted to say here, so this is in the US, right? Prior to 1900s, there was a lot of cannabis sold as drugs. Here's a bottle from Eli Lilly, cannabis oils they're selling. And sometimes they spell it out. Here's cannabis indica, cannabis, all that stuff. You look at all these bottles, right? 1900, this is before that. All of them are cannabis. That's what they say, cannabis, cannabis, cannabis. And now we're going to talk about the interesting sociology or culture behind this plant, because this is where things get kind of interesting. So before that, before 1900, right, everything's called cannabis medically. 1910 is the Mexican Civil War. When that happens, we have a lot of migrants that move from Mexico back up into the US because of the hardships. Almost 1,809,000 is what I saw. 1913, suddenly there's a law against marijuana use. Marijuana is the Mexican name for cannabis. It's not against cannabis use, right? This is used by white people. And it's not uncommon for that to happen. This happened in San Francisco, 1875, right? We had a lot of the Chinese come over, the coolie workers to work on the railroad yards. They had these opium dens. Europeans didn't like that. 1875, San Francisco makes a law, no more opium dens. They're illegal, no more opium dens. However, if you get opium by the form of laudanum, which is what a lot of women were using because of cramps and whatnot, that was totally legal. So you could take the same product, and if it's sold for rich white people, then you could do it, but if it was intended for other uses, it was not, right? And this is going to keep coming back. That's where the marijuana word actually comes from, right? It is the Mexican form of that. This is an interesting story. Henry Anslinger. Anybody heard of this guy? Probably the most influential person that you've never heard of. He was a pure bureaucrat. He was not a scientist. He was not a doctor. He just knew how to work the system. He was the first head of the Bureau of Narcotics, federal FBN, which is now the DEA. So he was the first head of that, and he was the head for 30 years. Over 5 presidencies, the same guy was the head of the DEA, right? Or as we call it, the FBN. He started as an alcohol prohibitionist. His quotes were, "Only depraved drink booze, those with strong constitutions do not." So he was very much an alcohol prohibitionist. That was his job. 1930, alcohol prohibition went away. This guy, in perfect bureaucratic form, said, okay, in order to protect my job, we need a new prohibition. And he turned to cannabis. And he was a racist like you've never seen before. I don't necessarily need to describe all these things. He has quotes that are just through the roof. This is a federal employee for the last 30 years, right? This is a good one. There's 100,000 total marijuana smokers in the US. Most are Negroes, Hispanics, Philippines, and entertainers. Their satanic music, jazz, and swing result from marijuana usage. This causes white women to seek sexual relations with Negroes, entertainers, and others. He hated this drug, right? You can see, on and on and on. He is just flamed this. There were people that did some science in time. They said, no, this is not true. People don't smoke and go criminally insane. But he completely ignored that. He charged through. The head of the DEA for 30 years. And he had a lot of help. It wasn't just him, but there's this whole thing of yellow journalism. It's surprising how things come around. Yellow journalism is what we call today fake news. Take something that has a lot of emotion and pound it out there. Randolph Hearst, right, the owner of San Francisco Examiner, was one of the key leaders of this kind of stuff, this news. Here's some San Francisco Examiner headlines, right? U.S. bear dope trade, traffic at girls. Murder, weed is ripe all over U.S. Dope officials helpless to curb marijuana. Growing menace in school children. All 1930s, right? This all Anslinger and largely Randolph Hearst kind of working together. This was an interesting story. This guy, Victor Licata, wild-looking guy, right? He murders his mom, his dad, his sister, and both brothers with an axe. Hacks them down to the bloody scene. Anslinger, in 1937, makes this testimony to the Congress. It says, here's a normal guy. We came to the scene. It was a bloody mess. And sure enough, he was smoking marijuana. So he puts this as up to, right to Congress. And the next year, marijuana goes illegal. It's an amazing story. One guy's pushed, so the story here, this guy's never smoked, or they found out later, he has nothing to do with marijuana. He was a nutcase in the very beginning. He did do it, but he had nothing to do with marijuana, right? He was just a nutcase. 1936, you heard of this one? Reefer Madness. I used to think this was a joke, but this was not. This was actually a movie that was put out at the time.
These high school boys and girls are having a hop at the local soda fountain. Innocently, they dance. Innocent of a new and deadly menace lurking behind closed doors. Marijuana, the burning weed with its roots in hell. Smoking the soul-destroying reefer, they find a moment's pleasure, but at a terrible price. Debauchery, violence, murder, suicide. reality. See this important pill now, before it is too late.
So this is the culture, right? This is what's happening, and we got the cultural thing, we got the racism thing going on, the anti-immigrants, all coming to a peak, all when this guy Aslinger is in charge of it. So a year later, the Marijuana Tax Act comes out, which means it's done. You got to get a license in order to grow marijuana. No one's allowed to have a license, so it's out of business. They put industrial hemp in the same category as marijuana. So when they made the marijuana tax, they also made industrial hemp illegal. And there's an interesting story here, right? Because a couple people, Randolph Hearst, who had all those stories about how bad marijuana was, how bad cannabis, right? He also had a lot of timber acreage, and he made a lot of paper. And it was clear to him that if hemp was legalized, he would lose business to the hemp market. The other one that was behind this was Andrew Carnegie Mellon, because he actually was the banker for DuPont, and DuPont had just invented synthetic nylon. And the last thing they wanted was hemp around, right, when they had synthetics. So there was this whole movement on both sides, from both the industrial side and from the medical side, that this should be illegal, and that's what happened. 1950, cannabis actually becomes criminalized to the extent of heroin, Schedule 1. Today, 2018, cannabis is still a Schedule 1 drug, meaning there's high potential for addiction, there's no medical use, and there's no safe level. This is the highest level of license you can get. It is literally, we're applying for license now for this. It is literally easier to get a license to cook methamphetamine than it is to grow a marijuana plant. Literally, one's a Schedule 1, and methamphetamine Schedule 2. So that's where we stand. So in this class, you know, we can't do research. We can talk about this later. So let me tell you one more story. So this is what happened in the U.S. We had a lot of hemp early on. We had medicines. For whatever reasons, and the cultural stuff is really fascinating on why it was so evil that we're living with it today, right? So what's happened in the meantime? So there's two stories here. An Israeli biochemist, Raphael Meshulam, because he's allowed to work with it, he said he got his hemp right from the police. I think they when they collected, he just went and said, hey, can I study this stuff? We're not allowed to do that. But he was allowed to do it. And what he did is he isolated THC and CBD. He purified them. He showed what those molecules were. He's the first one to do it. And then he asked this wonderful question. Okay, what do they bind in the brain? What are they doing? And when he does that, he isolates two receptors, he and some others, there's other people involved on this, but he was the driver force of this, find that there's two receptors, a CB1 and CB2 receptor, which are in brains. These are in human brains, they're also in your nerve cells, they're also throughout your body. These bind this THC and CBD, right? Then he asked, all right, that's fine, but what normally binds there? So what's the normal one? And it turns out there are these two fatty acids, it's anandamide and arachidonyl glycerol, which bind to those same sites. So now there's a brand new neurological pathway which has been identified, right? You can even cut out the THC. So these are phytocannabinoids up here because they come from plants. These are endocannabinoids down here because they're endogenous to you. This whole thing is considered an endocannabinoid system. So it's a neurological system which exists in all of us and in mice, and it affects lots of stuff. It affects, do I have it on here? Modulation, appetite, memory, pain. These are all, this is the cannabinoid system that does this, the endocannabinoid. And it just so happens that the plant has some action to that. Okay, but it doesn't stop there, right? Because this looks very simple. But this area has just boomed because here you have a brand new neurological pathway that affects appetite and sleep and mood. Talk about a drug, you know, That's a gazillion dollars for any of those things. You could get that. So people are studying this like crazy. And what you find is that there is complexity, redundancy, and promiscuity, meaning that these molecules bind more than one receptor. So here's what we're going to look at down here. Here's the anatomide, here's the 2AG. This is the endogenous receptors, right? And they're binding CB1. There's these transmembrane receptors. Here's CB1 over here. And what it's showing is where they bind, right? So THC, THCV, B, they bind here. We kind of knew that over here. But what we didn't realize, and this comes from this research, is it just expands, right? So now you say, okay, where's the 2AG? And now these other cannabinoids are binding different components to this. So you've got this complex system with a ton of receptors. All those receptors bind different cannabinoids. The same cannabinoid will bind multiple receptors. It's a systems biology, right? It's a complex systems biology. But it has beautiful potential for medical value there, right? Because of all those things. So Daniel Pimelli is the guy that kind of discovered a lot of this, and he's going to come talk about this, so he'll get into the details on this. Again, it's a completely new neurological system that has a lot of mood behavior to it, and now we actually have an in, because we know what molecules activate it and inactivate it. So that's pretty interesting. One more word that comes out, and I'll finish here. Typically in pharmaceuticals, the aim is to get one drug, one receptor. That's what we sell. And the reason they do that is because when they get racemic mixtures, then it kills people. So they like one molecule. This kind of system is very different than that. Because as I said, if you give people pure THC, they can't handle it. It's too psychoactive for them. But if you mix it with a little CBD, then it works. It brings it down. So and that's known. This CBD is an agonist of THC. So what THC turns it on, CBD turns it off. So you need both to be effective, right? And then you've got 120 other molecules which are presumably binding over here. And we haven't even started with terpenes, right? Which affect your bronchial, Vicks vapor rub, you breathe, you get your veins are opened up, right? All that terpenes, you go through a pine forest and you smell that pine, right? A lot of mood enhancing stuff. So this whole kind of system, and you'll hear this a couple times, go by this name of entourage effect. So it's not just one drug that's doing it, but you need a whole suite of 5 or 6 drugs or 10 drugs, and then that's how you're modifying behavior. It makes total sense, right? No one hormone works alone. It's not like auxin does something, right? It's auxin in response to everything else. And clearly in your brain, it's not one molecule doing it, it's going a whole bunch. So this has really changed kind of how pharmaceuticals work, and I think that's going to be positive. All right, acknowledgements. I've got hundreds of references here. I'm going to leave those someplace for you to look at, and that's it.